Hello all, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore, and in this July lecture series, we are discussing about modeling in virtual reality in medicine. And in the previous series, we have discussed about virtual reality and the input-output devices. After that, we have discussed about modeling in virtual reality. After that, we're going to discuss about model management. Already we have discussed about model management part 1, and this is model management part 2, which includes some techniques to improvise the virtual reality environment with the help of modeling techniques. Okay, what do you mean by this adaptive LOD management technique? In previous one, we have discussed about LOD management. What is this adaptive LOD management? Actually, adaptive LOD, it is an algorithm that selects LOD of visible objects based on a specified frame rate. The algorithm, it is based on a benefits to cost analysis, where cost is the time needed to render object O at level of detail L and rendering mode R. The cost for the whole scene is summation cost of OLR less than or equal to target frame rate, where the cost for a single object is cost OLR, it is equal to maximum C1 polygons of OL plus C2 vertices of OL and C3 pixels of OL. Here C1, C2, C3 are experimental constants depending on the R and type of computer. See here, we have to provide a real world experience in virtual world, so we have to use mesh type. With the help of mesh and with the help of combined mesh, we can give the polygons to give exact feedback in the VR environment. With that polygons, we have vertices, also we have pixels, so we have to map each and every pixel in the object to provide a better experience. Okay, similarly, the benefit for a scene is a sum of visible objects benefit, sum of benefits of OLR. For single object, we have summation cost OLR less than or equal to target frame rate for the whole scene. For single object, it is cost of OLR, and for a whole scene, it is sum of benefit of OLR, where the benefit of a given object is benefit OLR, which is equal to size of O multiplied with accuracy of OLR multiplied with importance of O multiplied with the focus of O and multiplied with motion of O, and also it is multiplied with the hysteresis of OLR. The algorithm tries to maximize each object's value. Here the value is equal to benefit of OLR divided by the cost of OLR. Objects with a higher value, large size, are rendered first. See here. Here we have, see the first one, no detail elation with 72570 polygons. See the second one, optimization algorithm. Here we have 5300 polygon and 0.1 second target frame rate, 10 fps. See here the first and second one, which gives more clarity, which gives minute elements in VR environment. See the first one, FPS, and the second one is, see here the second one, and 0 to 250 interval. We have to improvise our optimization algorithms to get better results. See the level of detail segmentation in a rendering mode. First one, no detail elation, 19821 polygons. And the second one, with the help of optimization, 1389 polygon with 0.1 second target frame time. The third one is level of detail, darker gray means more detail. So whenever we improvise our optimization algorithms, we will get better output in the VR environment. C. Another method is cell segmentation. It is another method of model management. It is used in architectural walkthrough. To maintain the virtual building illusion, it is necessary to have at least 6 fps. Necessary to maintain interactivity and constant frame rates when rendering complex models. See here, only the current universe needs to be rendered. See here we have viewpoints, lights and objects. Object 1, 2, 3, 4 and 5, and also we have lights up to 3 we have, and also we have viewpoint 1 and 2, and we may add or removing object from simulation. And the first one is entities ignored by the simulation manager. Second one is entities considered by the simulation manager. And we have to limit our universe and limit of application. First we have to limit our universe, and the second one is we have to limit our application based on the user needs. We have to define which objects are going to display in virtual world, which might be removed from object simulation. Based on user needs and user input, we can modify our VR environment. See here the cell segmentation, increased frame rate. Here buildings are large models that can be partitioned in cells automatically and offline to speed up simulations at runtime. Cell approximate rooms also we have, and partitioning algorithms use a priority factor that favors occultations, partitioning along walls. See here the room 1, room 2 and room 3 partitioning, and here we have coordinates x and y. Automatic floor plan partitioning is done with the help of VR software, VR modeling softwares. See here in cell segmentation, building model resides in a fully associative cache, but cell segmentation alone will not work if the model is so large that it exceeds available RAM. In this case, large delays will occur when there is a page fault and data has to be retrieved from hard disk. So we have to avoid this. See here the frame time, frames, and if page faults means the data cannot be retrieved from the hard disk. At the time we have to modify the optimization algorithms to give higher results. See combined cell, LOD and database methods. It is possible to add database management techniques to prevent page faults and improve FPS uniformity during walkthrough. It is possible to estimate how far the virtual camera will rotate and translate over the next n frames and prefetch from the hard disk to appropriate objects. See here user interface, visibility determination and look ahead determination. And the second element is detail elisions, and here the second one is cache management. And in the upper side we have render and we have input output operations, and last one we have monitor, and here we have database. With the help of database management techniques we can prevent the page faults. To prevent page faults, which gives a smooth virtual reality environment at the user side. See here the database management sample. Here we have LOD 0 to 3 and 0 to 2, 0, 1 and 0. 0 is lowest level of detail loaded first, and LO3 is highest level of detail loaded last. Here this is a perfect example for floor plan visibility and highest LOD. Thank you.